Hello everyone, and welcome. I am Darsh Kumar. This is session 2 of the Unity tutorial, and today we are going to make a first person shooter game, a, at least a prototype of it. So, I begin by creating a new blank 3D project. I'll call it like shooter prototype. And now it is creating the library. We'll wait for it to finish creating it. And now that Unity is opened, this is the default scene that we are able to see right now. I will uh, I will first put it to a layout which I'm comfortable with. I use 2 by 3, and in the hierarchy right now, the only thing that we have is the main camera and a directional light. And the first thing that we need to do is make sure our input manager is set up. That our project settings are set up according to what we need to do. Uh, so currently we need to modify the input manager so that it's not just about moving and looking around and firing, jumping. We also need inputs for scrolling as well as reloading. So I will make use of I will change two unused inputs, and I'll use them for our new purposes. Crouch for now, let's put it at C, and it's a key or mouse button. And the other one is for reloading using R. It's a key or mouse button. And now we have our input manager correctly configured. There is this Unity asset called the Unity Particle Pack, and it is very much useful when you are when you want to work with particles. In this project, we will be working with particles, so I'll import it to the project. Oh, right. Installing this particle pack just reset our input manager, so I think we will have to do it all over again. Since it was only like two inputs that we edited, so it's not that that big of an issue. And right now the only effects that we need are the weapon effects. The rest we can simply ignore. So all we add is the weapon effect example. So in our assets folder, we have our weapon effects which we will be using in this project. Oh, and also I had to redo the project settings again because it reset. Oh wait, it did not. Okay, okay, we're safe here because we did not import those asset settings. Okay. So the first thing that we do here is add the player as an empty object. Uh, Currently, it's empty because we'll be adding things to it as um, as more components are needed. So the first thing that we need for the player is a representation of it, and most of the time we use a capsule because there's the roundedness, it helps sometimes. But anyways, we have our capsule added, and we move the camera to be a child for the player object, so that it will move and rotate along with the player, and it should be, and the camera should be somewhere inside of the player capsule. I think 0.6 should do. Then of course we will be moving the player using scripts, so we will add components to it, the rigid body and a character controller. uh, we have our components for movement. We also need some ground to be able to walk on, so we'll add a plane, and that will be our ground. Call it the ground plane and position it to the origin. And then we can resize it later according to our needs. Right now I think a 20 by 20 should do. Yep. And our player is the player is clipping halfway through the ground plane, so we'll move him a little bit up. uh, okay, then we need the scripts so that we can actually move our player around. And since we will be using multiple scripts, it is advisable to put them in a separate folder. Most people use a folder called scripts. So we'll create a C# script, and it's for moving our player. I'll call it player control, and it's created um, a C# script. I'll open this with VS Code. And for some reason it all Unity always defaults by adding these indents as spaces, so I convert it to tabs. Okay, so we make our control script now. First we reference the character controller. I'll call it like player control. This is basically a reference to the component that we have added to the player. And no, we don't need it public. Vector 3 player well. This will store the current velocity of the player, and also the horizontal speed and jump height. Okay, and also gravity, how much we want it. It's 9.81, 9.81 f, and this f means it will put this number as a float data type instead of double, because if you have a decimal point it would default it to double, so we need to specify it otherwise. We don't need the start function because we won't be setting anything in the beginning. Update, we'll leave it for now, and we'll have our actual function for our movement. So the first thing we do is determine the direction where we want to go, and that is based on our input and as well as where we are facing. So I'll store it in a new variable. I'll call it move direction. It's horizontal axis, 0 on the vertical scale, and on the vertical axis. Okay, so what we're doing here is we're multiplying this quaternion thing with the new vector. Okay, so the the vector thing on the right, that's basically our inputs. That is the horizontal axis, using the left right arrow, or the on the joystick x-axis, or the A and D keys. That will be our x movement. Y movement, we're currently putting 0 because we'll have a separate logic for jumping. And this quaternion Euler thing, this is basically to take into account that if we're facing a direction other than the standard facing way, than the standard direction, which is here, like how the z, x, and y axes are shown, then we will be moving according to that, and not like you are facing uh, 45 degrees and you're still moving in the global z and x direction. So this quarter 9 takes care of that. And the next thing is okay, and then we move the player. We will move him using the character controller, and so we're moving it using the character controller instead of rigid body is because it's more easier, and we still added the rigid body because a character controller still needs a rigid body to move around. So character controller has a function move, which will help us move at time and player speed. So this time dot delta time, it's basically the time difference between the two frames that are rendered. So whenever you are moving, if you don't have this time dot delta time, it is the same speed over the frame but not over time. So this will correct any kind of jitteriness in the motion that you feel because of frame rate changes, and we're multiplying it with our player speed. The next thing we'll implement is the jumping. So first thing we need to know whether we are on the ground or not, because you can't jump in midair. So I'll have a separate boolean which will store the answer to this question, like either a yes or a no, true false. So this is basically the logical uh, it's a logical statement. Like if our game object's position y position is more than 1.56 or less than 1.6, we'll set ground contact to true. How I got these numbers is by empirical testing over various values. So and then jump is input dot get access jump 2.5. Oh right, this is another boolean which is storing whether or not we have the input for jumping. Then if we have our ground contact and we're jumping, we have our input to jump, we will add player velocity, right? Player's y velocity, it will become square root of player height into 3 into gravity. And in the end we'll also have the gravity implemented, and player velocity y, I'll reduce it by gravity into time dot delta time, and then we move in this new velocity we have specified for our y or vertical direction. Okay, we have our basic character controller where we can move around and jump. So let's see how it is working. Save it of course, and to the player we'll add our control script just like that by dragging it, and there are a few errors. Okay, it should be mathf. I save it, it's reloading the scripts, and okay, our packages have been done. So for player control we'll pass the reference of our character controller speed, and player jump height is 3 or 2 maybe. Save it, and let's just play it once so that we know if we're moving. We are not moving. Okay, so that is the thing about interpolate the movement. And let's have it at 2. Maybe it's with the collisions. No. Okay. Go to input manager if there is some problem here. Alt negative here. And yep, this is working fine. Oh, right. Okay, now I get it. We have a separate function for movement control, and we're not calling it during our game play time. So we'll just call this function in our update function so that it is called in every single frame. And now we should be moving. Yep, we're on the ground and we're rolling for some reason. And that is due to the rotation. So we'll freeze it for now. And yep, we are moving, but not jumping. Okay, right, because our character is 1.08 y, and we have it set for 1.5. So okay, we can change our values then. So this should be 1.0, and this I'll put as 1.1. We'll save it and let it reload. And now, does it work? Wait. Yep, and we are jumping. But from this angle, we're not able to discern any movement. That we'll fix a little bit later by adding some texture to it, just like how we did last time in session 1. So first we have our movement down, and the ground clip is also working properly. So we'll add our crouching mechanics also then. So for crouch, I'll have another boolean so that we know that we have our input for crouching. So crouch equal to input dot get axis crouch greater than 0.5 f. I'm putting the crouching before we do our final movement. So for crouching, there's two different methods. First is to actually rotate our object. The first way is to rotate our object in like our forward direction. This here it's z direction, I think. No, the forward direction it will change depending on where you're looking. So let's say like for 45 degrees here, rotate this way. No, this is not how it should work. Yeah, 45 degrees. No, negative 45. Yeah. So you can do this way, but then you will also have to angle the camera end as well. A much easier approach is to change the scale of our player. So I'll have another vector 3. It's a data type. It will just hold like 3 different values x, y, and z. So it's very useful. Target scale, because we are changing the scale of our object. So new vector 3. This is our normal scale. Like when we're not crouching, our scale is 111. Here you can see. So if we have our input for crouch, we'll change our target scale y component to 0.5, basically half height. Yeah, you can change it according to whatever you want, but 0.5 is a good middle ground. And okay, what we're doing here in this line is that we are we're changing the local scale of our game object, and we're lerping it. What lerp does is basically take an average between two values, and this average is weighted. So the lesser or this third value is, the closer it will be to the first value you specified. So this is a good way of smoothing out your movement, because otherwise it would abruptly change the scale. And we're done with the crouch, and let's see. Crouch button we have set to C, and look at this. It is changing our scale to 0.5. It is getting close to 0.5, but never equal, because you're just trying to move as close as possible. So we have our keyboard controls. Then Now we need our mouse controls. For that, I'll add a separate script. I'll call it player mouse control. So we've created our new file, and I go to VS Code. We have created new one, and as always, converting the indentation. Wait, yeah. Okay, so the first important thing that we need is the sensitivity. So now sensi, I'll have it 75. Anyone who's played any games, they would say like 75 is too big, but this is not the sensitivity that the user is choosing. This is the one which is preset by the uh, preset by the engine. So if we change our the sensitivity control that is given to the user, it's basically multiplying the input you have given with the with some value that is given in the engine itself. And next, we need to know how much we can turn. I'll call it min x minus 360 and max x. These are x rotation, and the same for our y rotation also. We need to know our limits. So I've chosen 70 degrees. Most games they would have the maximum y of 90 degrees, so that you're able to look straight up, and the min y, it is usually like 80 or 70. I keep it at 70 most of the time. So then we need our current rotation. Our current rotation and the original rotation, like of the object itself, and not the ones that we're having for ourselves. So, this time we are using the start function. So if we have our rigid body with us, so get component rigid body, rigid body, no. So this will freeze the rotation of the object if we have a rigid body with us. So we're freezing rotation so that it doesn't start moving on its own, and all the control is with the user itself. And we set our rotation to set our original rotation variable to whatever rotation our game object has currently. And the next thing we do is get our inputs. This mouse x axis is by default set by the engine. You don't have to, it's by default set by Unity. You don't have to do anything major to get and get it working. Mouse sensitivity, and of course smoothing it out according to our time difference between frames. And our Y rotation, we do the same for our mouse vertical axis. Um, Here we'll need to clamp the angles so that when you go to because we are adding or adding it to existing value, so there's always chance that it would exceed it. So we'll need to clamp this value. For this, we'll have to create a new function. So I'll call it angle clamp, and it will take 3 arguments: angle, minimum and maximum. So if our angle is less than negative 360, not 306, 360. If our angle is greater than 360, F. So here we are doing our what we're doing in here is when we get to like negative 360, that is going counterclockwise, and here we won't be able to go any further if we simply clamp it. We'll need to reset it to either 0 or wherever it is supposed to go, so that it's in between negative 360 and positive 360, so that you can rotate as many times you want, instead of being limited like one full rotation here and one full rotation here. And we clamp, angle, min and max. MathF already has a clamp function, but we created our own function here and called the MathF one because of how we needed the angle to be reset around 360 degrees. So we have our angle clamp done, and we'll use that function in our update function right after we get our input. So rotation equal to angle clamp or x rotation min x max x, and our y rotation the same way we're clamping it. Min y. So we've done our clamping, then we need to do our actual rotation. So this quaternion will store exactly how much amount to rotate the game object without in a manner that the game object understands. So Okay, and we specified how much we want to rotate, and then we apply the rotation. So local rotation, original rotation multiplied by our new quaternions. What the quaternine will do is keep the rotations independent, because when you are rotating using the normal these Euler axes, let's say I rotated the y axis by 45, our x and z axis I have effectively changed. So a quaternine will make sure that this doesn't get in the way. So we save our scene and add our player mouse control script here. And there is an error in line 40. Okay, this f has to be small. Now I'm moving my mouse, and as we see in the bottom left display are the angle at which we're looking at the world. It is changing, and we can move. And because we already tied our movement to the rotation of the object, we didn't have to change anything in our player control script. So our mouse control is done. Then this is a first person shooter game, so we need a gun. So I'll create an empty object and we'll call it the gun. So in there we first need the object itself. So I'll add 2 cubes, that will be our barrel and the grip. So we need to scale them up. Okay. So our x direction is here. Barrel is supposed to be long, say 0.8, 0.1, and 0.1. And our gun grip is 0.1 in the x, 0.1 in the z, and 0.5. No, 0.5 is too long. 3. Okay. Then we need to position them. We'll oh wait, which is our forward direction here? I think it's z. Let's keep it like 4 in front, and yep, z direction is in our front. So okay, right, we can't differentiate between anything, right? So let's add our materials in right here itself. I'll create a new folder for this. I'll call it materials, and create a new material right here. Okay, so our player will be a bright blue, and we'll apply it to the player's capsule. So the player is blue, and for the gun barrel and grip, in the effect examples and weapon effects, they already have the materials. So we'll apply the metal surface, so that we can at least see and differentiate them from the from the existing thing. The next, okay, this looks horizontal. We need it, so this should do. Yep, and yeah, this will do. And we need to bring it out. Z direction. 1 is too much. 0.6. Yep. And for this object, yeah, barrel. Nine five, yeah, and we bring it up by 10. Oh, oh wait, minus 0. No, positive 0.1, a little bit higher, so 2. Yeah. So this is our gun model. Wait, we will not need this. 0.6. So this is 0.35. We'll bring the gun itself forward. 0.5, no, 655. Okay, no, yeah, 6 was okay. Now we're keeping the gun centered because it is easier to calculate the bullets that way, but then it looks something out of Doom, right? Just the original Doom that was there. The gun is right down the middle and it looks boring. Oh, and also here, wait, I'll walk a little bit back or first and zoom. Okay. Whenever I'm crouching, look at this. The gun is also shrinking. We don't want that. That is not good. So so this is some problem with our crouching. So we need to edit our the crouching the script, and we need to make sure that it is working with our guns scaling. So for this, okay, we'll need to know how big the gun is. So I'll add another public variable, transform gun scale. So the gun's local scale our only changes are in the y direction. So what we can do effectively is have our x and z directions is 1, because we don't need to change the scale there. The only thing we need to change is here should be the inverse of our current scale that the parent object is in, and semicolon. So now if oh wait, okay, the variable gun scale has not been assigned. So we'll use our gun here. So now that the referencing is done, if I crouch, I mean, it is an improvement. But something feels off, like the gun shouldn't move like this much. So what most games do is add a second camera. Okay, so I'm adding a camera, let's call it gun cam, and we'll position this gun cam a little bit later. The first thing that we will have to do is add a new layer in here, and this layer is our gun cam view. Okay, all that the gun cam view should be able to see is just the gun. Okay, so we'll move this to gun cam view. Yep, change children, and this is culling mask, and put it to nothing, and just gun cam view. Depth 1, no. And the main camera, target display. Okay, depth, put it to 0, and this one has depth 1. Okay, so now that I've don't clear flag thing, we are able to see both the gun cam view and the main camera. So we don't want the main camera to see the gun. So go to culling mask and remove gun cam view. Now we have effectively just separated what the gun camera and the main camera are seeing. The gun camera is seeing this blackness in here. So we'll move this camera a little bit back, okay. -0.5, and move it a little bit up. No. And y is no, a little bit more, and ta-da. We have our gun which appears on the right hand side a little bit offset, but it is still not but you will still be aiming like right down the center of your main camera, which is how most games do it. We see in CSGO also, like the CSGO, GT, and etc. You're aiming through the main camera, and it doesn't matter if the gun visually isn't going through it. As long as you can see it, you're shooting at it. So this is a simple trick that all games use. So we have our gun camera and the gun scaling done. Okay, then okay, let's make the material for the ground, so that we know that we're moving. I'll open up Paint then, because Photoshop is installed in this system. I'll have it a little bit higher quality. I think 512 should do. We don't need this high res, but okay, yeah, this is good middle ground, because like the higher resolution of textures you're using, the more video memory you will consume, and it will basically make your system go haywire. So I definitely would not recommend. maximum size. And a little bit darker tone so that there is a transition. Okay, so this is basically our flow texture that we will use, and just so that it doesn't like look completely boring, I'll add a little bit of uh, dark splotches, like just so that mixing it. No, no, it's not looking good. This is good enough, and we'll save it in the assets folder, materials, let's say, and we have our flow texture. We go to Unity, and it's already imported. So we go to ground plane and we add a texture to it. Now it's just one massive blob. Just like last session, I'll dial it. Let's say 50 times. No, 50 is too big. 60. Yeah, yeah, 60 works. Okay, we are basically done with having some kind of texture so that we know that we are moving. Yeah, we have a gun, but we can't shoot it. So let's change that, and also remove this audio listener because it will just keep giving you this warning. Okay, before shooting, we'll need some kind of script that will manage our health. So let's do that first. I'll call it player health, and it's created. I'll go to here, player health dot cs, and this is a little bit easier on us. Right, of course, convert indentations to tab first. Okay, we just need like two values which can be seen by everyone, and that's our max health and our current health. Whenever we start up our script, we reset the health. This will be a function that we will create. Update function, that will be not needed because we're calling this function externally when we're doing the gun shooting script. So the first function we need, which can be used by everyone, so we need it public, and that is our reset health, and it is current health should be equal to max health. It's that easy. And then we need another one that we're taking damage. And by how much? Minus equal to amount, we're reducing it. And if our health is negative, we put it to 0. So this is a rudimentary health system that we have. We add this to the player, and now we are having so many components. I'll just shrink them. Player health, maximum health, maximum health 100 as always. And okay, we have the health down, and we need a way to shoot the gun. Okay, we're very close to completion. Okay, so I'll create a new script, and it's gun shooting script. So it's created. We go to gun shooting script.cs and change indentation, of course. Here we need a lot of stuff. So first thing, our clip size and our remaining clip. This is our player position. We'll need to know that because of how we'll handle the bullets. And oh right, and the hit object, the object that will actually hit. Wait, okay. So the object that will actually hit. So when we start, we basically reload first. This will be a function that will create reload gun. And yeah, then we just do our input, like if fire 1. This is our default firing button, the left click. So if we have our input for firing and our remaining clip is greater than 0, that means we actually have bullets with us. We shoot our gun, and it's another function that we'll have. And also, if we have the input to reload, the button that we specified when configuring the input manager, we named it reload. We reload the gun. So first thing that we'll implement is actually shooting the gun. So void shoot gun. First thing we do is have a layer mask. We saw that we separated our scene into different layers. So we'll need another layer which will handle all of the players that will handle everything that can be hit by the bullet. So I'll add another layer, and that should be bullet raycastable. And for now I'll move the ground to the bullet raycastable, and also this should see, our main camera should see everything other than the gun cam view. Okay, so the next is our ground plane is in a new layer, which is layer number 7. So we'll need a layer mask. What this layer mask will do is, I'll explain it a little bit later, and this is an object which stores a raycast state. So if physics dot raycast player position player position dot forward out hit infinity and layer mask. Okay, so so let me explain. First up, this raycast, we're basically just throwing a ray into the game object from our player pose dot position in the direction of in a forward direction. Okay, and whatever it hits, it will be stored in this object, which is this raycast hit object, and it will try to hit something within infinity, that is basically any distance possible, and before and it will only look for objects specified in the layer mask. So that's what the layer mask is for, so that we can specify which objects it can hit. So we draw ray, we will just draw a ray, and it will not appear in the camera itself, it will only appear in the in this in our scene viewer. Okay, this is for debug purposes, so that we can see if it is working or not. And we get our hit object. Okay, now if our hit object is an enemy, what we'll do is hit object dot get component the enemy's health, which was in our script, and dot the take damage function that we did, and let's say we put it to 25 HP of damage. Now this is very high damage considering we only have like 100 health and 25 is basically 4 hits. But this is basically a prototype. You're just trying to test something or trying to learn. So if our hit object is enemy, we do this, and we we're still shooting. This raycast was to determine if we hit something. So we put so we reduce our remaining clip by 1. Now there is a chance that it will go into negative, but it's basically eliminated because we are already having a check before calling this function that it is greater than 0. So if it is 0, you won't be able to shoot the gun anyway. Then we need another function that will reload the gun. And it's just as simple as our previous object player health script. So we have our gun shooting script ready. We place it here, and this time we'll attach it to the gun itself. And there is an error, cannot convert Unity Engine transform to vector 3 line 27. Okay, debug to draw. Okay, player position dot position, it needs the position. Okay, and now yep, we wouldn't see any errors. Now we start okay. Oh right, we didn't specify the clip size. Okay. And now okay, it's not calling the function. Okay, variable has not been assigned. Okay, oh right, we did not assign any object to it. Okay, player transform. Now it should work. Let's see. Yep, you see in the debug we're drawing a line if we're hitting an object. See, it's here. So we are drawing an object. We're drawing only in this scene viewer, and we don't have any kind of way of knowing if it is working. So that's what we had this part in this asset imported. It was not for just the gun material, but also it's got a prefab for the muzzle flash that will that's basically the gun's muzzle flash, and it looks like this. We'll angle it properly and place it to 0. So we need to position it. I think is 0. Oh wait, should be 0.2. Yep, and as 0.9, I guess. Yeah, and we'll scale it down. I think 0.3 and 0.3 and 0.3. Now it's appearing in the center instead of in front of the gun. For that, what we'll do is wait. Okay, we'll just put it to bullet ray. No, not this one. We'll put it to gun cam view. Let's change children, and yeah, we got a muzzle flash in front of our gun. Okay, we need to push it a little bit back. Yeah. So we have our muzzle flash. We'll need a way to uh, to play and pause it. So we'll edit our gun shooting script. For this, of course, it's the Unity's particle system. You can just do almost anything. I'll call it like muzzle flash. So when you start, the muzzle flash shouldn't be playing, so we'll keep it stopped. And if we shoot, we'll play the animation. It's not even animation, it's just a particle simulation. So we'll play this particle simulation, and we'll need to wait for the particle to finish before we can do the we need a way so that we can wait for for this animation to play. So what we'll do is we need to wait for some time. So I'll have another boolean, we'll call it waiting, and this will be doing exactly opposite. Okay, and we need a function, and it's was shooting. Wait for seconds. 0.15 f. Why 0.15? Why wait for like 0.15 second? That's because our start lifetime is 0.15. That's why we're just matching them. And you just stop it here, and okay. Okay, so what this start coroutine is doing is basically pulling another thread into the script and waiting for that thread to finish before moving forward. So what we're doing is where we start our muzzle flash animation. Wait, we don't need this waiting boolean. Okay, so we start our muzzle flash. We start the coroutine, which will call this enum function, and this function will wait for 0.15 second, then stop the animation, and then we go on with the remaining clip thing. I'll save it, and we can see how it is working. Okay, we have an issue. The name short sparks does not exist in the current context. Oh wait, right. Oh, it's muzzle flash, sorry. And okay, we got our shooting script. For the muzzle flash, we just pass this prefab that this is here, and we got the particle system working. So I play, I click, and yep, it's playing our animation. And let's reduce the bullet size to 12 so that we can quickly determine if the reloading is working. So we have the bullets are at 0. I am clicking and it's not doing anything. I press R, the remaining clip goes to 12 and we can shoot again. So our gun shooting script is done. So we have health, we have ammo. We'll need a way to see all that. So we need a canvas on which we can put everything. This looks very big, but don't worry because we won't need too much of stuff. So I'll call it the player HUD, heads up display, and screen space overlay. So what this will do is it will overlay the camera on top of the display, overlay this canvas on top of the display, so that you can see everything. So in this I will add a text. It's a text box for the health text, and another one for our ammo text. So we have we added both of these, and these are just two new text. So I'll just call it health so that we can differentiate between them, and ammo text. So health, I think I'll place at the bottom right. So our pivot position at bottom right, so that we can just put 0 here, another 0 here, and we're at bottom right. Width, I think 300, and we'll make this on the right. Also constant pixel size, no, we need constant screen size, and our reference Oh, okay. Okay, there were some issues. Okay, so so far what we've done is added move the player to a separate layer so that the AI can see him through the raycasting. Uh, so since the player is in a separate layer, we put the capsule as the one that will be seen by bullets, and so we'll change our gun shooting script. Then uh, okay, for the AI script, uh, we'll change it. We'll change it a little bit. So if uh, raycast position transform dot forward out hit, that dot infinity layer mask. If we get a raycast, and if hit dot collider dot game object equal to player. So if our game object is the player, we know the enemy will engage. So look at, so the enemy will turn around to look at the player, and if hit distance, now we move to the fun part, like which if the hit distance is say 20% of the line of sight, we should move away. Otherwise, if hit distance is half of the line of sight, we shoot. Otherwise, if it's within the line of sight, we move towards the player. So this movement is why we had our character controller referenced. But first, about the AI gun, there's a problem here that it is shooting every frame. That is not what we want. What we can do is have a separate timer that is running. Okay. So timer and our short time. Timer is time dot time. Okay, so shoot gun. If you're doing, if you have shot it, right, we're updating this timer every frame, so input it here. Short time Oh, right. Short time. Okay. So if our, let's say, short time uh, let's say 0.2 seconds, you can only take a shot like in 0.2 seconds every time. uh, Only then you will be able to shoot. Let's see. Float does not contain a definition for time. Okay. Let's put it to a simple var and see what it does. Okay, local variable. Okay. We can currently ignore this one for now because it can be implemented by taking a look at Unity documentation or just looking it up on the internet. So I'll just leave it at that for now. So the enemy controller, we shoot the gun if our gun dot remaining clip is greater than 0. Okay, I'm doing this here again because we'll be reloading from within this script and we need to give an input here. So yeah, gun dot reload gun. Okay, right now we don't have any kind of movement configured, so this AI, it will just sit. All compiler errors. Short time does not exist in current context. Okay. Okay, there's also another problem here. Because our object doesn't have any movement script, it is ignoring gravity. Okay, that we'll fix, but first we need enemy control. Our player is this object, AI gun, and AI control. Line of sight, let's call it 30. Okay, yeah, let's call it 30. And okay, let's try and running it. We're not drawing any rays. Okay, so what we can do here is use the player control scripts, the gravity thing. Enemy control, control V. Now we'll need more objects here then. Vector 3, player velocity. And gravity. Okay, we got our velocity and gravity. We go. We check for anything else regarding player velocity. Okay, there is nothing else. So this is called AI control here, and yeah, that should work. Oh god. Okay. And now this, yeah, it is not ignoring gravity now, and we're drawing our rays properly. That means our enemy should be losing health. Yeah, the health is at 0, but we don't have anything that should that can replace it. We don't have anything that these objects should do when the health reaches 0, but that can be added later on. And I guess we're done with this now. uh, with that, we come to an end of the session. We made this alpha looking game. Okay, the movement was remaining just a little bit. Okay, it's just two lines of code. I'll just put it fast, and we'll end it there. So we go to okay, AI control move negative transform dot forward, because the player is too close. We want to go back, and delta time, and we do the opposite here. We move towards the player, dot forward time dot delta time. We save it, let it reload. You remember in session 1, like we were it was not that good with the loading times, but here it is not, because of the way we configured this. Look at this. The AI is just going haywire. It just wants to shoot us so hard. Look at this. And I move this far, and it's slowly creeping up on me. It reaches its threshold distance, and it starts shooting. And for some reason now it's looking down. Okay. Now I'm moving too close. It will slowly move back, and that's it. I can maximize it. We can play this. I'll save this project, and let's just build this for Windows x86 and okay, build. Should prototype. We'll put it in this result folder. And we're done. This is our shooter prototype, and I run this. We get this made with the Unity thing, and look at this. Okay, the mouse is still there, but do you look at that? This wants to fly. Huh. Oh, stuck. Okay. This kind of thing happens with when you're trying to make a game. You try stuff. You try stuff. You fail. You learn all that stuff, all that jazz, and that's it. Thanks for watching, and I'm out.